in the future. So yeah, so this class is gonna be our basically the second to last class um of this module. It's not the second to last class of like this whole thing. It's still halfway to go. So we're still together for a little bit. So after this section, so this is gonna be the last section that has new material. So new material as in say we're just gonna look at the data structure, the rest of the data structure functions and just one more data structure. Um and we're gonna do an overview of the final project, which will be next week. And next week, once we finish our final project, that concludes the first module of this class. And the next module will be a more advanced class where I'll teach you just the problem solving skills on how to do things. I just want to, I guess, give you guys like a warning, I guess, like something to watch out for. The slides on that class is mostly just problems and solutions. So there's like not much lecture because the best way from my experience and how, well, at least how I learned how to solve those problems was to just try, right? Try hard on those problems and um well, of course you guys also have to know the like the things we learn in this class, right? You have to be familiar with like how a for loop works, what a function is, what variables are, data structures. Like you have to be familiar with all those, everything that we learn in this class. So there will be like I will like spend time to try to help those people that are still maybe confused about the material that we learned in this section. Because if you don't understand the material in this section, and you also have to understand it like well, like you have to like be able to like just like know it very deeply and very well. Because if you don't like the class mostly teaches on how you think to solve the problem, right? You have to know how to like once you think about a solution, like you have to know how to like write it into code. So that I hope that like the problems that we solved already, like you have like a general idea. Like for example, a problem might be like think of one of the easier problems, like find the median of a list, right? So the median of a list is just given any list in not in any particular order. So the median is just the middle value of a list, right? A median value of a sorted list. So if I had like values like 2, 1, 3, I want to find the median of this list. So how I find the median is I would first sort it and then I'd find the middle number. And if it was odd, then the middle number is just that number. But if it was like an even thing, then I have to take like this plus this divided by two. So like that's one of the easier problems of like the second module. So like finding a median of a list. There are some other more challenging ones, like maybe I don't know, like cut a string in half and then like put it like that. I don't know. Like if it was like hello, then like maybe I would do like I put like this. I don't know. Like some things just like the problem solving skills that like you'll need to know. And this applies to like everything in coding. It applies to web development. It applies to game development, like making games, algorithms, like AI, if you guys are interested in that, and like basically everything in computer science will rely on your problem solving skills, which is what the second module will teach you. So again, it's very, very important that you understand everything we learned from this first section and like you understand it very well. Like if I were to ask you to explain a for loop to me, you should be able to explain like what a for loop does very well, right? So I know like right now there's still two more classes left. So again, please ask any questions that you have like I guess you're confused about because like I don't know, I just want to help you guys, right? So it's very important that you guys just understand everything. And if you don't, just let me know, right? We have office hours and you can always ask me during class. I'll always spend time to try to help you guys. But I just need to like stress this. It's very important that you know you understand everything in this section so then you'll be able to do good in the next section because I don't want you guys to like feel frustrated or like give up, want to give up. Um because like the second module is gonna be pretty hard. It's not okay, not pretty hard. I feel like it's challenging, but like you just have if you know everything from this first section, I think you should be fine. But I just don't want you guys to feel like frustrated and just like give up. because you guys are like smart kids and you guys have a lot of potential to do well. So, but I just want to let you guys know that you have to understand everything we learned so far in this class to move on to the next section. Okay, just want to get that out there. Again, if you have any questions, just any uncertainties, you can ask me during class like right now, or you can just come in office hours and I'll try to help you guys. But like it's just very important that you guys understand um like things we learn in this class or in this section, so then you guys will do good on the next section. Okay, so yeah, just that. So today I'm gonna skip the review and practice because we're like a little behind on time, and I'm gonna also skip the fourth week's homework. Actually, I'll do the fourth week homework explanation because the cool thing about this class is there's just not much to learn. Like we have a couple of data structures, like functions that we have to learn, and like one new data structure. So it's like it should be not as much material as like compared to like the other class we learned. So today should be pretty chill, but you guys probably should still listen a little bit. Okay. So again, any questions, just let me know. Because it's very important that you understand all these things. Okay. Because we will be using basically every single thing we learned um on the next section. Okay. The next section, it's gonna be fun. There's a lot of really cool things that you guys will see and experience and just think about, and it's gonna be very cool and very fun. But um, you know, in order to let it be cool and fun, you have to know the material from this section. Okay. So let's just quickly get started. I'll stop talking as much. But let's just look at the fourth week's homework because I'm gonna skip what we learned last class. So remember last class we learned about a bunch of data structures, the list, tuple sets, and also all the functions. So hopefully you guys know what the function does. I also haven't had time to grade your homework. Sorry about that. I'll try to I'll try to grade it by soon, as soon as possible. So you guys can get the feedback. I'll definitely get it done by before we move on to the next section. Okay. Because the next section, the homework is literally just gonna be I'm gonna give you a problem and hopefully you can solve it. And remember, there's always office hours, right? You can always ask me in class. So I just want you guys to know these things. Like, if you have any questions, just please don't feel discouraged. Like maybe when like if it's hard, just don't feel discouraged, right? Like it just takes time and it takes practice for you to understand, right? So you gotta like be patient and just do the work that you need to do, and you'll be fine. Okay, and I promise you that you'll be fine. And if you're ever like you don't know something, just please ask in class or just come to office hours, and the help is always there. Okay, so let's go over homework 4. Um, so the homework 4 class 5 was when we learned about functions and stuff. So homework 4 is basically a temperature converter. So how you convert things to temperature or Celsius or Fahrenheit, um, you probably have to search it up on Google, because I didn't expect you guys to just memorize the formula, but the formula for this is the answer, but the formula to convert Celsius, so Celsius, wait, let's look at this. Celsius is equal to I think it's the Fahrenheit. So your Fahrenheit temperature minus 32 divided by 5 and then times 9. Okay, so this is the Celsius conversion and Fahrenheit. So you get this from Google. You probably could have found it from Google. It's equal to the Celsius temperature, right? The Celsius temperature times 9 divided by 5 plus 32. Right? And if you were to if any of you guys have taken algebra before, you know how to move things like around and just um show from this, you could get this as well. So you can trust me, they're the same thing, and we just got them from Google. So how we would do it, well, we would have two functions, right? One to convert Celsius to Fahrenheit, and one to convert Fahrenheit to Celsius, right? So again, now we have two functions, right? Hopefully you guys remember how functions work. So you guys want to type in the chat, what is this? What are these called? Like these things inside. And it's not a variable. Like what are they called? So after this class, there's only be one more module. So we have the beginner and then we have the advanced section. So there's only two in this class. So yeah, this is a parameter, right? This is a parameter. So it's not a variable, it's a parameter because remember a parameter? Does anyone want to explain what a parameter is? Maybe you can like unmute or like type in the chat. Any of you guys want to explain what it is? And also, some cool one. Okay, one sec. One cool thing I found. I hopefully it works here. Um, One cool thing I found is something called captions. So if I'm ever talking too fast or like um, on too like I'm not loud enough, maybe my mic is kind of bad. You can see that like on the bottom of your screen, you can see like the text of what I'm saying, right? It's kind of cool. It's like maybe a half a second delayed, but if I'm ever like too quiet or like talking too fast, you can always read the like the text on the bottom. It's like pretty cool. I like just found that out. So I just wanted to let you guys know. So like maybe if you like can't hear me or my mic is kind of bad one day, I don't know. But I'll enable that from the rest of the classes because I think it might be helpful. To just like just in case, you know, my mic gets bad or something because I have like an old mic. So yeah. Okay. Does anyone explain to me what a parameter is? Oh yeah, so a parameter is basically variables for your function, right? It's basically just variables that are specifically for your function, right? Meaning that only your function knows these variables, right? Okay. So again, um, this basically again, it's just a formula that maybe I shouldn't erase the formula, but it's basically just a formula to convert Celsius to Fahrenheit. It's basically just saying, okay, we you know multiply by 9/5 or multiply by 9 divided by 5, and then we add 32. So that's how we convert Celsius to Fahrenheit. Okay, and to convert from Fahrenheit to Celsius, we first subtract it by 32, and then we multiply by 5 and then divide by 9. So remember, we had to do parentheses here because remember the order of operations, right? Since we want to subtract 32 first, right? Then like if we didn't have it, then Python would think, okay, I'm gonna follow the order of operations. And if I were to do like this instead, right? Minus 32 times 5 divided by 9. Right. Which one would get evaluated first? Will it do FAH minus 32? Will it do 32 times 5? Will it do like 5 divided by 9? Like which one would happen first, according to the order of operations of this? Will it be
32
this?
times 5.
Yeah, 32 times 5, right? Because remember, you know, PEMDAS, multiplication and division always comes with 4 addition or subtraction, right? So this will be evaluated first. Well, we don't want that, right? We want this to happen first. And in order to do that, the only thing that's above, let me write this down. The only thing that's above a multiply or divide, okay, the only that's above a multiply or divide is a parentheses, right? So if you were to put a parentheses here, this will automatically get evaluated first, right? Which is what we want, right? We want this to get done first, right? And then after, if we were to do this, and then we just multiply by 5. So, and then after here, remember these are just, hopefully you guys know how inputs work by now. Also one lucky thing is for your questions, you won't have to use input. Like they'll automatically assign a variable to you. Like they'll give you like x equal to 3 or n equal to 7. Like the variables will already be given to you. So you don't have to worry about that. And so you won't have to use input, but input is just useful for this class. So hopefully you guys know how inputs work as well. So we're just getting the Celsius degree in int and the Fahrenheit degree in int. And I probably could have done a float as well, but I think the problem statement, I think it said like it'll only be a whole number. So just to keep it basic for int. And also after we just printed Celsius, remember the comma just prints on the same line with the space in between, right? So we put the Celsius degrees Celsius to Fahrenheit is, you know, and then we call the function, right? Remember the function will return something. So when it returns something, this will become whatever it returns. So for example, if I were to do, okay, let's look at this one because it's easier. If I were to do F to C and I gave FAH as 32, right? This will print FAH, so 32. So print 32 space degrees Fahrenheit Celsius is space F to C, which is what I passed in 32, right? When it returns, this thing will just become a number, just become a number, right? So 32, 0, 0 times anything is 0, right? So this will just print 0. So 32 degrees Fahrenheit to Celsius is 0 Celsius. So does that make sense? It's been like a while on the homework, but does that make sense? It does. Okay. And maybe I could do this. I don't know if you guys can hear me better. Um, but hopefully you can. Hopefully you can. So yeah, this is the Rebel link. I'm not too sure if it works anymore because Rebel deleted a couple of my other Rebels, and I don't know if this one got deleted as well. So because of like the whatever. But okay. So yeah, let's just get into lesson 7. So this is gonna be the last lecture. And by lecture, I just meant like it's gonna be the last thing where last class we will learn new material for this section. So just for the section. Okay. So and today all we're gonna learn about are some more data structure like functions and a for loop extension if we have time. So let's just quickly get into it. So let's just learn about the final data structures that you'll need to know um to solve like basically any problem. Like these are like the most common things, right? Like 99% of problems can be solved with the functions that you already learned. Maybe like more than 99%. So yeah. Okay. So this is the min function. So all the min function does is min takes in, so whatever. Okay. Wait. Min takes in um a list and it finds the smallest value inside of it. That's it. That's all it does, right? So how we do it is we'll do min, like you can see in this format. So we'll say min, right? Min, yeah, like minimal, like the minimum number, right? Um, so min, right? We do the parentheses, and inside the parentheses, we just give it a data structure, right? We give it a list, right? It's just usually a list. We'll give it a list, right? And when we give it a list, right? All it'll do is it'll find whatever value in this list. We're gonna find the smallest value. That's it, right? We're gonna find the smallest. So what's the smallest value in this? It's gonna be 1, right? 1 is the smallest value. So, and min returns a value. So when we return a value, you can think of it as it becomes like some value, right? So let's just look at this example real quick. So when we do list equals to 55112, right? 551112, right? This value, right? Min list will become min list. So all we do here is we're gonna pass in this list, right, into min, right? Because this has the value of this, or like this list, like LST has a value of this list, right? So when we pass in the like this list into min, they'll just give me the smallest value, right? It's gonna be 1. And now when it returns, so min returns the smallest value. So when we return the smallest value, this you can think of it as it becomes 1, right? It doesn't actually happen. It's just how Python does it, right? Like in the back, like in its own system, right? So now min list equals the value of 1. When we print min list has the value of 1. So that's what you get. Does min make sense? And then next one is gonna be max. So max is like the opposite, I guess. So instead of finding the smallest value, you'll find the biggest value. That's it. Make sense? Does min and max make sense? Oh, sorry. Okay. Okay. Hopefully min and max make sense. So dot index, dot index might be a little more confusing than min and max. So what dot index basically does is it returns the index of the specific element in a list. So it returns the index of the value in the list, right? So basically it gives you the position of the value in a list, right? Where the value is inside of the list, right? So let's just look at this format. So we will always pass it in a list, right? You go list, the list itself, right? Dot index, and in the parentheses, we give it a number, right? And this is basically in English is saying, okay, we want to find the position of the element in this list, We want to find the position of the element, which is the value inside of the parentheses. We want to find that position of that element inside the list that we gave. So, for example, if the list with this LST was equal to apple and banana, right? I did, and remember, this also returns a value, right? So when I do list dot index banana, right, it's gonna give me one. Well, why does it give me one? Well, when we pass in this list, we're basically saying, okay, so this list dot index banana. So banana is the element. List is this list. This list, this is this, right? So what we're basically gonna do now is we're gonna say, okay, what position is banana in the list? Okay, this is this the apple is in position 0, and the banana is in position 1, right? So when we have that, it's gonna return 1, right? Because banana is in position 1, it's in index 1, right? So now it'll return 1, right? Because bananas in level 1. And when we print, so this should be IDX. When we print IDX, right, we're gonna get 1. So does that make sense? How min, max, and index works? Because I think that's all we have for this. Yeah, that's it. So let's just play with like this thing a little bit. Um, just so like we can just get more familiar with it. So I want everyone right now just to open their REPL, open their Visual Studio Code if you have it. Um, you can just open something. So can you guys see my screen right now? Can you guys see the class7.py screen? Oh yeah, Denny. So hopefully you guys can see. Okay, if you guys can see my screen,
Is there something else you can use like other than REPL, like not downloading a software or something?
oh, okay. Yeah, if you can't download a software, you guys can go on online GDB. The only issue with online GDB is I don't think it saves your code unless you make an account. So you can just go here and then this is C++. So I think how you change it is okay. So if you guys don't have if Rebel doesn't work and you don't want to download like Visual Studio Code or anything, you can just go up here just for this class. But hopefully you guys can download VS Code, Visual Studio Code, by maybe next class or by before the second module starts, just so you can have a place to write and save your code. But just for today, because it's just not much, you can just use as practice. Just go here, and then just go on the top right. On the top right, there's a language, like a language thing, and just select Python 3. Click on it, and then you can just delete whatever the text is in here, just delete it, and then you can write here. So I guess since we're all using it, I'll just use it like here today. So let's just go over some guided practice. So I'm gonna skip this for now. Let's just play with some stuff, right? So x equals, let's just say give it my list equals to 1, 2, 3, 4, 5, 6, 7, right? All these values. That's kind of hard to see, sorry. But if I were to do the minimum equals to min of my list that I printed minimum, what do you think this will give me? What will print out? Yeah, Danny?
1.
Yeah, 1, right? Good. So if I were to do that, you can see that 1 appears right here, right? 1. We get 1. Why? Because 1 is the smallest value in the list, right? If I were to do max, right, 7 will get printed up, right? Why 7? Because 7 is the biggest number in the list, right? And if I were to do my list dot index 4, and um, I were to print the my index, my index, what value will get printed out? Let's try it. So well,
5.
3, 5, 5. Oh, okay, yeah. Wait. Okay, yeah. Three will get printed out, right? 3 because 0, 1, 2, 3. Or 4 is in position 3, right? And also, if I were to do this, we'll get printed out 3, right? Well, why doesn't it prick this 4? Why does it pick this four? It's just because this four just it's it appears first, right? It'll find the first appearance, right? If I put a four back here, I'll still get three, right? It just finds the first one that appears from left to right, right? If I were to do like eight, what do you think will happen? Eight. If I did eight, what do you think will happen? We get an error, right? This is an error. Why? Okay, maybe I don't think I think I might have forgot to mention it, but if the value doesn't exist, you'll get an error. That's it. So if the value doesn't exist, you get an error. So make sure when you use dot index, make sure you know the values in the list. Right? Just make sure you know the values in the list. Right? If I did it two, I'll get one. Right? Because two is in position one in the list. Right? There's an index one in the list. So does min, max, and index make sense? Can we, is that good? Yeah, Danny?
No.
Oh, sorry, what? I think you
Uh,
were like cut off a little bit.
so it's like no, because like if it's the maximum and it's two, then it give you error.
Wait, can you repeat your question? Sorry.
Uh, no, because like if it's maximum and then it was select as two, then like it's going to give you error.
Uh, wait, you're saying, are you talking about index will give me an error if I put in two?
Wait, are you talking maximum or minimum?
Oh, I'm talking about dot index.
Oh,
Yeah. Um, so if I were to do max my list, right? This just gives me the biggest number in the list. So what's my biggest number in this list?
7.
Yeah, seven. Right. If I did to min, the smallest number in my list is one. Right? Like this won't give you an error if you write it correctly. It basically just says, okay, I'm gonna find the biggest number in this list, or I'm gonna find the smallest number in this list. Does that make sense?
Yeah.
Okay, 1, 2, 3, 4.
Okay, let's move on. So now, skip the guided practice. Do we have time today? Yeah, I want you guys to try this. Actually, you guys don't have to try this. It's not it's like kind of we could just skip it because for the interest of time, right? Also I lied. There's one more thing that we have to do. It's called sum. So sum basically just finds the sum of all the values in a list. That's it. So this just goes like every single number, adds them all together, right? So it follows like the same format of as min and max, but instead of like min or max, you just have sum. Right? And for sum, you just pass in a list. Right? Once you pass in a list, it just finds the sum of the list. Right? So 4 plus 3 plus 2 plus 1 plus 5. Oh, what do you mean without writing the whole expression? Like without writing like x equals the sum list? You mean like that?
Like without writing like the stuff in the list like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah 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 100.
Oh, yeah. You could do that, but like would you think sum would be like a good way of doing it? Or like could we use something else that we learned? Um like a for loop or you know, like something. Yeah, sum wouldn't be as great, right? Because sum only takes in a list, right? If I wanted to find the sum from 1 to 1 million, I wouldn't want to put in 1 million values into my list, right? That's just like kind of stupid, right? So what I would do is like I would have like sum, my sum equals to 0. And what could I do to iterate all values from 1 to 100? And what could I use? Would I use a for loop? For loop? Would that help? Like a loop, like for I in range 1 to 100 or 1 to 101 because it doesn't include 100. So if I were to, let's just say, let's print I. Wouldn't this give me all the values from 1 to 100? Right? I can even do like 1,000. So like kind of like, I have to scroll like a bit. Like, doesn't this give me all the values from 1 to 1,000 or 1 to 100? So, well, if I wanted to find all the values from 1 to 100, can I do my sum plus equals to equals to my sum plus I? Yeah, I can also put I into a list. Like if I were to do LST, I could also do like, how do we add these into a list? What function is that? Is it dot, yeah, dot append. Right. So if I were to append I printed so just and just to make sure that we get the same value, I'm also just gonna do this as well. And we're gonna print, so we're gonna first print my sum of, so we should see the same number. And we do, right? 5,050, 5,050. So it's like the same thing. So it would just be better to use a for loop in this case. Yeah. Cool. Does that answer your question? Okay. Hopefully it does. So let's just go over, and we're gonna skip 2D lists because we're not gonna get into it that much. Maybe we're gonna have like one problem that has it, but you could think of it as a 2D list gives you like a row and a column. So a 2D list is a list inside of a list, right? So we basically have 1, 2, 3. You can like list it out in like a column form, like a grid form, right? Where you put like one list on top of another, right? And this is like your column. These are your columns and these are your rows, right? So now instead of having one index, we're gonna have two indexes, right? And first we're gonna say index of the embedded list, right? The list, the values inside, and the value inside the index of the element inside of that list. Right. Okay, that probably didn't make sense. But basically we're saying, okay, if I wanted to get the value 2, right? I'm gonna ask myself two questions. Okay. First, which list is the value 2 in? Is it in this list or this list? Is it in list 1 or list 2?
1.
Yeah, it's in list 1. Right? Because 2 is in list 1. Right. So first, we're gonna first index by which list the value is in. Right. It can be in this one or this one. Right, and then 4 being the second one, right? So this is the first index. So this will be the first index, right? And what I want to do now is my second index, my second question should be, okay, inside that list, right? Inside that list I just chose, right? Which index is 2 in? So inside of this list, right? Which index is 2 in? One, right? So now this will give me 2, right? If I were to do this, right? So how it works is basically just saying, I'm gonna ask myself two questions whenever I want to use a 2D list, right? I'm gonna ask myself the list, the values in, right? And I want to ask myself inside of that list, right? Which index is that value in? Does that kind of make sense? You don't have to know it too well. This might just pop up on one question, and I'll just try to explain it again when that happens. But hopefully that kind of get a general idea of how it works. Does that kind of make sense? Like a little bit? Kind of. Okay. I'll take a kind. You don't have to know this like in at least for a while. When it comes up, I'll explain it again. Okay. So, and here's like a visual if you want to just look at it. And you don't have to do this question. Okay. Actually, no, you don't have to do this. So let's just skip the guided practice again. So let's just go over into our final section. There's like 10 minutes left, but if you guys can stay until 4, like 5:10 or something, um, we we can just go over time because I had some sorry about the technical issues today. So let's just go over this final section. We're gonna learn about dictionaries today. So this is gonna be the final data structure that we learned. So in total, we've learned 4 data structures, right? We learned the dictionary, the list, the set, and the tuple. And in the next section, the most you'll use is a list. Then I think the second most common will be a dictionary, and the third most common will be a set. And you'll basically never use a tuple. So sets are just basically better than tuples in a lot of ways until you start getting to memory, which I don't think you should worry about. But we'll basically be using sets, dictionaries, and lists a lot. So just be careful about that. Just try to see if you can understand this today. Okay. Remember, if you have any questions, just let me know. So dictionaries they're very special. They store values in a very special way, and they store it in something called a key value pair. So a key value pair is basically a value will be paired up with another value, right? They'll be in pairs, right? And one value will be a key, and one value will be a number will be a key, or a type of data will be a key, and a data will be a value. I can't really say value, right? Like in data, I mean by like an integer, a float, string, a list, doesn't really matter. Could be any data, right? But usually we'll be using either integers, lists, or floats as the key value, the data inside a key or a value. Okay. So a lot of times I'll be using like the word maps. So a key maps to a value, right? And what that means is basically says, okay, this key has a certain value, right? And this key maps to a value, right? And so yeah, that's just like kind of the general idea of what a dictionary is. So dictionaries are, again, they're ordered, they're mutable, and they're heterogeneous. So you'll dictionaries can be heterogeneous, but they're not that useful. Like heterogeneous dictionaries are not that useful. That means most of our problems, I think all of our problems will be using dictionaries with like all the same types. Like it'll either be all integers and occasionally an integer and a string, but it'll usually just be all integers, right? So every key will be an integer, every value will be an integer most of the time, at least for this class. Okay, so how we define a dictionary is we use a sorry, I'm like some water, sorry. Okay, so we define a dictionary very similarly to how we define a set, right? And we define it with these swirly brackets, right? These swirly braces. So they're the same. The only difference is now we have a key mapping to a value. So basically we have a key, a colon, and a value. And that basically states like this will basically state that a key maps to a value. And that is one element inside the list, right? That's a single element inside of the list. So let's just look at this example. So a dict, right? Dict is short for dictionary, right? And this is how we define a dictionary, right? And we give it and then I also just contradicted myself with this heterogeneous, but it kind of just shows you how key value pairs work, and it also just proves that it can be heterogeneous as well. But we don't use heterogeneous dictionaries that much. Okay, so this is a key. This is a value. This key has the value 1. So usually how it'll work is we'll see that this key apples has the value 1. Apples has the value 1, right? And it'll basically just say, just apples maps to 1, or you can think of it as apples has the value of 1. right? And bananas has a value 2. And this might be useful like if you want to count how many apples do you have, how many bananas you have, right? You can think of it as like um a big collection of variables, right? Like a big collection of variables. Or maybe I have like apples equals to 1, bananas equals to 2. It's just like a big collection of variables, right? And each variable has like a name, right? And that name is the key assigned to a value called a value. So do dictionaries make sense? Sorry, I think I need some water. So does that make sense? Yeah, Danny? Cool. So let's move on. Okay. So you don't have to know this. Well, you probably have to know this. So anytime you want to count, process, or remember elements, you can use a dictionary. So the most important thing is going to be counting. So maybe if I wanted a list, right, and I wanted to find the frequency, right? How many times one appears in the list, how many times two appears in the list, how many times three appears in the list, right? I can use a dictionary, right? And like my dictionary will probably just like 1, 2. Why? Because well, now I can say okay, 1 appeared twice, 2 appeared once, 3 appeared once, right? And I'll show you guys how to do it in a second, like how to write it. And also one thing about dictionaries is dictionaries are always sorted, and they're sorted by the key. So the key will always be sorted in increasing order unless you change it, but you usually never change it. So a key is always stored in increasing order. So that means like you'll never have a dictionary that looks like this. Unless you specifically define it as so. Right. So and also every key must be unique. So this is kind of like a set as well. That's why you have like the braces are the same, right? Because a key, you can only have one key. Like this is not possible. This isn't possible. It's not possible. And it's not possible because they have the same key. That's just not how it works. Right? So that's just some extra things about dictionaries that we have to do. So how you add key value pairs into a dictionary is probably pretty important to know how to add key value pairs into a dictionary, right? The keys in dictionary must be unique. Remember, they have to be unique, right? And if yeah, I'll show you with an example. So let's just say an example. I started with d equals to, so which one is one a key or a value? Is one a key or a value? Key or value? It's a key, right? It's a key, right? Because the key is always first, colon, value. Key is always first. Okay. So when we do this, the key is always first. Yeah. So when we do this, we're basically saying, so this is how you add something into a dictionary, right? So when we add, how you add into a dictionary is what we do is we'll give it the brackets. It's kind of like indexing. We'll give it the brackets, and we'll say this is the key. I'm going to assign it to a value. We're going to assign it to a value, right? So now 2 is going to be my value, and 2 is going to be my key, and B is going to be my value. So after I do this, my dictionary will look like this. Does that make sense? So when we do indexing, right, this is going to be our key, and this is going to be our value, okay? When we add things to a dictionary. Does that make sense so far? Okay. Cool. So now we can also access something by their key, and you'll always access something by their key. Okay. So, and because keys are unique, so it's like better to access it by their key. And Python just does it like that. So you'll always be accessing something by the key. Okay. You'll always be accessing something in the dictionary by the key. So when we do this, right, when we do print d colon brackets 2, sorry, brackets 2, we're not, this is not indexing, right? This is different, right? Since this is a dictionary, this is saying, I want to get the value, I want to get the value of the key 2. Just remember our dictionary now looks like this after we did that. Right? This is saying, okay, I want to get the key. I want to find this key value pair with the key as 2, and I want to print the value inside of it. It should be, if I were to do 1, this is the key value pair with the key 1, and I want to print the value, which is A. That's why you get B and you get A. Does that make sense? Okay. If it doesn't, just let me know. Okay. Okay. So, and also when we're doing this, right, we're trying to access something by the key. Remember that the key must be inside the dictionary or else it doesn't work, right? The key has to exist, right, inside the dictionary. If it doesn't, then it doesn't work, right? So when you're trying to access some key value pair, right, make sure that the key exists. Okay. Does that make sense? Sorry, I'm like, yeah, but hopefully that makes sense. Okay. So let's just do a guided practice real quick. Um, let's just go for like 10 more minutes. I just want to go over this guided practice. So I want to say, okay, given a string of numbers, okay, I didn't teach you to how to iterate through a string. I think it's like a good time to teach you how to do that as well. So given a string of numbers, you want to use the user input, and then we want to use user input just to let them type in a bunch of numbers, and we want to count the amount of times every single digit number appears in that string. So we want to count how many times 1 appears, how many times 2 appears, how many times 3 appears, how many times 9 appears, so on. 0 appears, all that. And we're gonna skip the second part because if there's time, we'll do it. But let's just get this first part. So we're gonna count the amount of times every single character appears. So I want everyone just to go to their place to write code. You can go in your REPL, your VS Code, your online GDB, whatever. And let's just do this. Let's solve it. Right. So I'm just like just got back from like string 6. So it's just like kind of not on it today. Sorry about that. But let's just solve this. Okay. So let's just write a user input. Right. Does anyone want to type into the chat how you write a user input for a string value? A string value.
Is class over?
So yeah, since you could leave right now if you have something to do, but I just wanted to go over this and also just want to introduce our final project, which is gonna be a fun game. But if you want to leave right now, if you have something like to do, you can also just leave. Okay. Okay. So yeah, Anna gave us a good thing. So input equals string. Cool. And this is good. But remember that inputs are always predefined as a string. So this is like unnecessary. But it's good. It still works, but it's just unnecessary because inputs are always like pre-made a string. Yeah, yeah, you can leave. You can leave right now. If you have something to do, you can leave right now. And hopefully don't kick me out if there's like another class. But let's just quickly go over this and then we'll be done. Okay. So now we have this input, right? And now how we iterate through every character in a string is we have to do for I in range len input. Let me show you how it works. One, two, three, right? So how it works is when we print, okay, so you can also index a string, right? And it'll just give you all the values, all the characters inside of it, right? So when we print the length of the input, we're basically saying, okay, how many characters are there, right? And I just print all the characters. Right? Yeah, if you have to go, oh, you can go. Yeah. Okay. Let's just define a dictionary. Let me quickly just write the code and then I'll explain what happens, right? So sure. Invalid syntax. Okay, so think about it. Okay. So you can see that this is correct. You have 1, 2, 3, 4, 1, 2, 3, right? There's 2 1s, 2 2s, 2 3s, 1 4. Right. So yeah. So okay, this checks if I is a key in okay. Wait, you know what? Since everyone's gonna okay, I'll go over this next class. Because I think there's like a class after this, and I don't want to like disturb their time. So I don't want to like go too overtime. So we're gonna continue this next class, and I'll also just post the homework and stuff in the whatever, and then we'll just finish whatever where we left off next class, okay? Because next class, so there's just not much as well. It's just a final review and things like that. Okay, so you guys are all free to go if you want, and then I'll see everyone next week. Okay, and remember to come to office hours if you have any questions, which is tomorrow, 7 to 8 p.m. I'll see everyone next week or tomorrow.